Welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. From today we shall be looking into the method and algorithm of three-phase load flow. So far we have talked about the different modeling aspect of different components. Essentially we have talked about the modeling of transmission line, both the series part as well as the shunt part. And we have also looked into detail how to model a three-phase transformer. We have considered different types of connections. Essentially, we have considered different types of common connections Y or D, and we have also looked into that how to incorporate their vector group into the modeling. Now, so then therefore, for the purpose of three-phase load flow, we shall assume that we know that the model of a transmission line is given by, so we load flow, and the first part of this is network modeling. So in the case of network modeling, we are actually going to talk about, essentially there are two components: transmission line and transformer. So a transmission line, if it is connected between bus I and J, so this is bus I, this is phase A, phase B, phase C, and this is bus J, phase A, phase B, phase C. So this transmission line, as we have seen, so this can be modeled as a series 3 cross 3 matrix. So it is 3 cross 3 matrix, essentially the series part. And the shunt part, which we actually divide into two parts, equal two parts, that is also represented by two 3 cross 3 matrices. We have already looked into that how these 3 cross 3 matrices are built, so we and similarly here also. So you see, this is essentially nothing but the pi model of the transmission line. So this is essentially the three-phase pi model of the transmission line. So we call this matrix as Z series, and we call this matrix as Y shunt, Y shunt, Y shunt. And if this is, and this has got a voltage of VA, I say that this voltage is VIA, VIB, VIC, and this voltage is given by VJA, VJB, VJC. So then therefore our notation for the voltages is that when I say that my voltage is VIP, this means that this is voltage. These are all complex quantity. So I would say that complex voltage at bus I corresponding to phase P, where of course P is A, B, C. So P can be A, P can be B, P can be C. Now here the current, let's say that I say that this current is IA, IIB. So let's say this current is IA, IIB and IIC. Now this current has got two components. So this is another current, this is another current, this is another current, and I say that I have another current here, another current here, another current here. So I say that this current is, let's say, I shunt II, which is going to shunt corresponding to phase C. This current is I shunt corresponding to phase B, and this current is I shunt corresponding to phase A. This current, I would say that this current is IIJA, that is the current which is going from bus I to bus J. This current is IIJB, and this current is IIJC. Similarly, I have currents here, this current, this current, and this current. This current is IJIC. So this is I mean basically this current is from bus J to bus I corresponding to phase C. This is IJIB. This is IJI corresponding to A. And I also have, and this is IJA. This current is IJB. This current is IJC. And then similarly I do have this current, I would say that it is IJ shunt A. This current is IJ shunt C, and this current is IJ shunt B. So obviously I can write that IA is equal to II shunt A plus ij just by applying KCL. I is equal to I shunt B plus ij B and I is equal to I shunt C plus ij C. So here essentially the all the superscripts they do stand for the phase ABC. So I can write down that, so it is applying KCL. So essentially I can write down that IIA in vector form IIJA, IIJB, IIJC. Now IIJA. Now if this, now please note Y shunt is in 3 cross 3 matrix. So I know that IIJ shunt, now I know that, now let Y shunt is a 3 cross 3 matrix. In fact, I should write down that it is basically, instead of saying Y shunt, I should say YIJ shunt. So I should say this is YIJ shunt. This is also YIJ shunt. This is series. So what is YIJ shunt? YIJ shunt is the half line charge susceptance matrix of line between bus I and bus J. So I would write that Yij shunt is essentially, so let us write it, that Yij shunt is half line charge susceptance half line charge shunt susceptance matrix of the line between bus I and bus J. Similarly, Z IJC, I can say that it is Z and Z is C I, no, Z I J is C we have said, so we must is series impedance matrix of the line between bus I and bus J. So now you know now. So we said that it is Yij shunt. So Yij shunt. So Yij shunt is, let's say, is given by a 3 cross 3 matrix. So it is basically, say, let's say uh, Yij shunt AA, Yij shunt AB, Yij shunt AC, then Yij shunt BA, Yij shunt BB, Yij shunt BC, Yij shunt CA, Yij shunt CB, Yij shunt CC. So essentially, so we define that Yij shunt PQ is nothing but element of Yij shunt matrix connecting phase P and Q. So they essentially the relationship would be, as we have already said, but we are just simply recalling Yij, no, II shunt. Here it would be C A B II shunt. So it is I, so then II shunt A, II shunt B, shunt C is equal to essentially this matrix. So this is the connection between two voltages, Yij shunt A, Yij shunt AB. Please note all these are complex quantity. Yij shunt AC, Yij CC, and then it would be VIA, VIB, VIC. Now, if I say that this vector is termed as, now let's see that this vector is termed as I shunt A B C. So this is a vector 3 cross 1, or rather let us write it properly. So now let define that I shunt A B C is equal to I shunt A, I shunt B, I shunt C. So this is a vector. So basically this is a 3 cross 1 vector. And let's say that similarly VI A B C, this is defined as VIA, VIB, VIC. Right, so this is also a 3 cross 1 vector. So then these I can write down, this I shunt A B C is equal to Yij shunt into VI A B C. Right. Similarly, I can write down that I J shunt A B C is equal to Y I J shunt V J A B C, where I J shunt A B C would be given by, where I J shunt A B C is given by, where I J shunt A B C is I J shunt A, I J shunt B, I J shunt C. So this is also a 3 cross 1 vector, and V J A B C is V J A, V J B, V J C, transpose. So this is also a 3 cross 1 vector. Right. So these are the relations between the bus voltage and the shunt current which is passing through the shunt elements. Now let us look at the series elements. So now we have ZIJAC. Now ZIC is, now here again Zijac is actually a series branch impedance matrix of the line between bus I and bus J. So now let y I j a c is given by z I j a c inverse. So this is nothing but the series branch admittance matrix. So this is nothing but the series branch admittance matrix of the line between now let us define let also yijac is, let's say that we redefine it as yijac corresponding to phase ABC, and this is given by yijac aa yijac ab So this is a 3 cross 3 matrix, and I define essentially PQ is actual element of the yij series AC matrix connecting phase P Q, where P, Q are A, B, C. Similarly here also P, Q are A, B, C. Okay, so we stop here and we will carry on from this point onwards in the next lecture. Thank you.